Welcome to this presentation on winter or cold season flooding for the National Weather Service's Flood Safety Awareness Week. We'll talk about the different types of flooding that occur in the cold season, being winter and early spring. Flooding occurring in the winter can come from three main sources or a combination of the three. Snowmelt. As temperatures rise in early spring or during a winter thaw, snow will melt and the liquid from that snow will become surface runoff. Because the ground is usually still frozen, little to none of the liquid will be absorbed into the ground and will flow into rivers, streams, and other bodies of water, causing rises in water levels. With snowmelt and rain, warm temperatures melt the snow in combination with rainfall, both of which become surface runoff. This leads to significant amounts of water entering the rivers and streams, quickly raising water levels as well as flooding poor drainage areas. Ice jams occur when ice blocks the movement of water downstream, usually near an obstruction like a bend or a bridge. This causes water to back up and flood upstream of the blocked ice. Also, large chunks of broken up ice may move out of the river and onto land, damaging structures, property, and roads. Ice jams can be caused by snowmelt and rain or during a thaw. When snowmelt occurs, it can be the equivalent of an entire season's precipitation running off all at once. Most often, spring melt of the snowpack is a relatively slow phenomenon. Snowmelt rates are usually comparable to light or moderate rainfall. However, if the snow melts quickly enough and is accompanied by moderate to heavy rainfall, flooding can result. Such was the case on April 26th and 27th of 2011, when thunderstorms and melting snow led to flash flooding in the Lamoille River basin of Vermont and across portions of the northern Adirondacks. On April 26th, the combination of much above normal temperatures, record snowmelt in the mountains, and several lines of showers and thunderstorms caused major flooding with numerous roads from Essex County, New York to Essex County, Vermont, closing due to flooding. There were several reports of bridges being washed away. The total damage caused by the flooding in Vermont was $6 million, while figures in Essex County, New York were near $4.5 million. There are several factors that typically contribute to snowmelt flooding in the winter and spring. High soil moisture conditions prior to snowmelt, usually from a wet fall the previous year, can reduce the ground's ability to soak up melt water. If the ground is frozen, runoff will be enhanced by the impervious frost. An unseasonably heavy snow cover will store more water to be available for snowmelt. Heavy rain contributes more water for flooding and can also warm a cold snowpack, causing a faster melt. Rain on snow events are watched carefully for this reason. Unusually warm periods with high humidity and nighttime temperatures above freezing can cause snowmelt rates to be much more rapid than normal. Higher river flows from snowmelt can often spur the breakup of river ice, creating ice jams. In Vermont and New York, ice forms over rivers each winter. In most years, the ice will cover the entire river and can grow over a foot thick. Ice jams occur when the solid cover of river ice is broken up by higher river flows rather than slowly melting away. The ice floats downstream and a jam tends to develop where there's an obstruction to the natural flow, such as along bends in the river, along the intersection of rivers and streams, man-made structures like a bridge, or thicker ice cover. The ice piles up to form an ice dam, forcing water levels to rise quickly. Ice jams can result in a rapid and dramatic rise in water levels along major rivers and smaller waterways. Ice jams are unpredictable, and the depth and speed of rising water impounded by an ice jam can vary greatly. In some instances, communities have many hours of lead time between the time an ice jam forms and the start of flooding. In other cases, the lead time is much less. The January thaw of 2008 allowed snowmelt to increase water runoff into area streams and rivers, which caused some abnormally high water flows and some localized ice jams. This resulted in water levels to exceed their banks, with some very minor flooding, specifically along the Ausable River in New York and the Missisquoi River in northern Vermont. Combining ice jams, rainfall, and snowmelt can cause flash floods. Heavy spring rains falling on melting snowpack can produce disastrous flash flooding, while melting snowpack may also contribute to flash floods produced by ice jams on creeks and rivers. Thick layers of ice often form on streams and rivers during the winter. Melting snow and/or a warm rain running into the streams may lift and break this ice, allowing large chunks of ice to jam against bridges and other structures. This causes the water to rapidly rise behind the ice jam. If the water is suddenly released, serious flash flooding could occur downstream. Huge chunks of ice can be pushed onto the shore and through houses and buildings. Ice jams may also develop in the early winter during what's called the freeze-up stage, when ice forms within a river during spells of extremely cold temperatures. The ice can restrict the normal flow of water on the river, which can result in flooding. Ice jams can result in scouring of the riverbed and bank erosion that may lead to bridge or river bank failure. Ice jams can damage the stream channels and improvements so that overall vulnerability to flooding is increased. In the United States, ice jams cause approximately $125 million in damage annually. In order to provide advance notice of possible flooding, the National Weather Service issues flood watches and warnings. A flood watch means that flooding is possible within the next 12 to 36 hours and preparations should be made in case of flooding. A flood warning means that flooding is imminent or occurring and immediate safety actions are necessary. Thank you for viewing this presentation on cold season flooding. For more information, visit us on the web at www.weather.gov/Burlington, like us on Facebook, or follow us on Twitter.